Hello, Geometry and Honors Geometry. We're going to do the same guided practice problems for Lesson 10.3 on March 24th, Tuesday. First, we're going to start by including in our guided practice notes some theorems that will be useful to working out our problems in this lesson. We'll start with theorem 10.3, and you're noticing that I have two chords drawn into my circle, and each of those chords are noted as congruent. So here's what we know based on those congruent chords, that arc AB is congruent to arc CD if and only if the chords A, B, and CD are in fact congruent. So the if and only if means that this theorem goes both ways. If AB is congruent to CD, then arc AB is congruent to CD, and if arc AB is congruent to CD, then it must be true that segment AB is congruent to segment CD, those being chords. Next theorem. Theorem 10.4 shows us a circle with two chords drawn in. If the segment QS is a perpendicular bisector, that means it cuts a line segment in exactly two congruent pieces. If QS is a perpendicular bisector of line segment TR, or chord TR, then segment QS is a diameter of the circle. That is necessarily going to be the case. Theorem 10.5. Theorem 10.5 says if segment EG is a diameter and if EG is perpendicular to DF, then it must be true that segment HD is in fact equal to segment HF and arc GD is congruent to arc GF. So let's just take a look at that a little more closely. Here we have EG as a diameter, and we have EG perpendicular to DF, then HD, this segment here, is equal to HF. These will be congruent segments, and it will also be true that this arc GD must be congruent to GF. So basically this diameter cuts this chord into two congruent pieces. It also cuts up this arc from D to F in two congruent pieces as well. Theorem 10.6. Theorem 10.6 gives us two chords in a circle that happen to be congruent. And if that's the case, then it will be also the case that from the center of the circle to each of these chords, the perpendicular distance from the center of the circle to each of these chords will also in fact be congruent. Now remember, when we are calculating the distance between a point and a line, or between a point and a line segment, that distance is calculated based on the perpendicular segment that connects that point, in this case the center of the circle, to the segment of interest. Okay, now we're going to work some problems based on these theorems. For guided practice 1, if we are told that the measure of AB, this arc, is 110 degrees, we're to find the measure of BC. Well, there's no calculating to do on this problem because if these chords are congruent, which they are, they both measure out at 9, then those arcs will also be congruent. So if AB is 110 degrees, then BC will necessarily also be 110 degrees. Guided practice 2 refers back to this same diagram. We're told if the measure of arc AC is 150 degrees, that's this arc here, we are to find the measure of AB. Well, here's what we know. We know that if we add arc AB plus arc BC plus arc AC, we'll have made it all the way around the circle. So that means that all the way around the circle we'll have 360 degrees. So all three of these arcs, A, B, B, C, and CA, will add to 360. And that's what I've written here. But we also know it's true that the measure of arc AB is congruent to the measure of arc BC. We figured that out in our last problem. AB and BC are the same measurement. So assigning x to the value of either one of these arcs, we can now say that 2x, that is arc AB plus arc BC measuring out the same, plus the 150 degrees that we're told AC is, must be equal to 360. Then I just solve that for x. Subtract 150 on both sides. 2x is 210, divide both sides by 2, and it must be the case that the measure of AC must be 105 degrees. Guided practice 3. We're going to use the diagram we see to the right for guided practice 3 through 6. So anything that's marked in over here was given to us. with these problems. That's given information. And the first thing we're going to do is find the measurement of this arc CD, which is labeled as 9x. Well, because this is a diameter from B to D, that cuts this chord from C to E into two congruent segments, and it also means these arcs are also cut into two congruent segments, so we know then that 9x must be equal to 80 minus x. That's what we've written over here. 9x is equal to 80 minus x. Adding x to both sides gives us 10x is equal to 80. Dividing both sides by 10 gives us x is equal to 8. And therefore now we can say the measurement of CD must be equal to 9x. Since we know x is 8, we will plug in 8 for x, and 9 times 8 is 72. There's our measurement of CD. Well, that leads us right into guided practice 4. Whatever the measurement of CD is must be the same as DE. They're congruent arcs. So with really no further ado, we can jump right to the measurement of DE is 72 degrees. Here I've just noted that those two arcs are congruent. I've said what the measurement of the first arc is. CD is 72. And so I can conclude the measurement of DE must also be 72. Okay, now we're looking for the measurement of CE. So when we're looking at our circle, I'll bring it back in a minute so we can put these together. We're going to know that CE is the measurement of CD and DE put together. So let's take a look at that. CD and DE put together gives us CE. We know both of these are 72 degrees. We've already figured that out. So now we just add the 72 plus the 72, those two smaller arcs, to make the bigger arc CE, and the measurement of CE is 144 degrees. For guided practice 6, I've rewritten the diagram that we need here. So the first question is, what is the length of QR from here to here? And since we're told in this particular diagram that CU is equal to CV, they're both 12, so that's given information. Well, the distance from the center of the circle to each of the chords is congruent. They're both 12. That means these chords, in fact, are congruent also. So since ST is 32, QR is also 32. Number 7, we are to find what is the length of QU from here to here. Well, we're going to know that QU is going to be the 32 degrees, the total length from Q to R, divided by 2, which gives us 16, because CU here is a piece of the diameter of the circle, and that diameter of the circle would, of course, be bisecting that QR. A diameter will always bisect a chord. And so that means that this QR is going to be cut exactly in half with that U as a bisector. So QU is 16. Finally, our last guided practice problem together, we are to figure out the radius of circle C. How do we do that? Okay, well, I've taken the original diagram that we were given here, and I'm rewriting what we need down here to figure out the radius of circle C. Okay, so we've already figured out that from Q to U it's 16. We did that in guided practice 7. And we were told that from U to C it's 12. We got that from our original diagram. And so now we're going to draw a segment from Q to the center of the circle, which of course will be the radius of the circle. And that's what we're trying to figure out. How long is it from Q to C? What is the radius? So I'm going to label that X. Could have labeled it R, but I chose to label it X. I'm going to use the Pythagorean theorem to figure out my X. This is a right triangle. So these legs, 16 and 12, squared and added, will be equal to my hypotenuse squared, and I'm labeling that hypotenuse as X. That will be the radius of the circle once we figure out what X is. Here we go. By the Pythagorean theorem, 16 squared plus 12 squared is X squared. And then I'm working out the solution to this equation. 16 squared is 256. We probably have that memorized by now. If not, we can work it out on our paper. 12 squared is 144. I do want you to have that memorized for sure already. If not, today's the day. And that is equal to x squared. When we add these together, we have 400 is equal to x squared. Take the square root of both sides, and x is 20. Nice perfect square there. So this is actually a Pythagorean triple, 12, 16, and 20. And we're done with our guided practice for our lesson for today, 10.3. So it's now time to make sure all of what we've written down here are in your notes, in your guided practice notes. And now it's time to complete the homework for lesson 10.3. And I'll see you next time.